All right, so we already looked at the derivations of the cosine of a sum and difference and the sine of sum and difference. This video will take a look at the tangent of sum and difference, and now we can use the identities that we have previously proved. So we can use sine and cosine of a sum, and then the quotient identities. First thing we will do here is we'll change tangent into sine over cosine. And then we'll use the two sine of sum and cosine of sum identities. I'll just write those off to the side. And you can also look at your identity sheet. We're just going to expand using these two identities. And as we're going through these, just keep in mind some of the differences between the sine and cosine and similarities. So with the sine, the functions that are grouped together are different, but the plus or minus sign in the middle is the same. I actually just wrote the wrong one there. Hold on, let me fix that. For the cosine, because we're using cosine of a sum, the functions are grouped together. So cosine and cosine are grouped together, sine and sine are grouped together, but the sign in the middle is opposite. So we'll expand these out, sine A, cosine B, plus cosine A, sine B, all over cosine A, cosine B, minus opposite sign, sine A, sine B. And then our next step, we are going to focus on what I have highlighted in green. So we're going to look to change this cosine A, cosine B into 1. We're going to use this technique that we've already used. We're going to multiply the top and the bottom by something. Now in this proof, I'm going to show this in 2 steps. And then you can combine these 2 steps into 1 in the next proof if you feel comfortable. And if not, you keep going with this result. So again, I'm highlighting this in green. And really what I want to do is divide. So I'm going to multiply by 1 over the cosine A, cosine B. That will get us the 1 in that location. And then hopefully everything else will also simplify nicely once I do that. So this step that I'm showing here, we can just do it this way. What I'm actually going to do is distribute that into everything. So we'll make this into sine A, cosine B, over cosine A, cosine B. And this is the step that you can skip in the future if you feel like you're able to. To an extent, because we were only able to simplify one thing at a time when we're doing this. So there's a lot going on here. There's the fractions and the fractions. Make sure I wrote this correctly. Okay, so the first thing I'm doing is simplifying anything that will cancel out into 1. So if I cancel out the cosine B's on top, I'm left with sine A over cosine A. If I cancel out the cosine A's, I'm left with sine B over cosine B. The entire thing right here cancels into a 1, which is what I was looking for. Minus, and then this is going to stay sine A over cosine A. I'm just going to separate it into 2 fractions so that it's easier to see my next simplifying step. So I'm just going to put can skip in the future. I think for this proof, the first time you see it, it helps to have it all distributed in to see what cancels. But you at least need to show this step here and the previous 2 steps, and then you can jump right down into the current step that I'm at. Now, everything that's left is a quotient identity. So because it's the same reason, I can change all of these into tangent all at the same time. This is a little longer of a proof because of the fraction. So if you look back at the top, I do have the identity that's on the other side. So we're going to do this one more time. I'm actually going to skip the step that I said we can skip. If you want to keep that step, then you're basically copying down the same proof that we just did, except the signs will be opposite. So this is tangent of a difference. And if you look at the identity on your identity sheet, even though there are two of these, you're going to memorize them or learn them in groups because they really are the same thing. So we want to notice here, kind of like sine, it's subtraction on the numerator because the original tangent A minus B is subtraction, and then it's the opposite sign on the denominator. But this and the tangent of the sum, they look very similar. So you're learning it as a group and then just noticing what's different about each of them. So we'll do it the same way. We're going to change to sine A minus B over cosine A minus B. And here we're using, forgot to write my can use on the side. We're going to be using the sine and cosine difference formulas. And we're going to be using the quotient again. So use the quotient, I'll expand sine A cosine B minus, so notice that the tangent and the sine both use that same sign from their original, and then cosine A cosine B plus sine A sine B. And same result that we're doing before, we're trying to change that bottom left corner into a 1. So we're going to multiply the numerator and the denominator by 1 over cosine A cosine B again. Same exact step. And then if you need to distribute it through to see what to cancel, you can add that step in. I am skipping that step right now. I'm just thinking about what would happen if I distribute this into each of these spaces, right? So I will end up with sine A over A, or cosine A, minus sine B over cosine B, because the other cosines will cancel, over 1 plus sine A over cosine A times sine B over cosine B. So I'm eliminating that other step. If you feel like you need that other step, go back to the previous proof and add that into this one. And then we get tangent A minus tangent B over 1 plus tangent A tangent B. And just like before, we just have to scroll back up a little bit. Actually, we can see the top of this to make sure that we prove that it looks like the other side. So that concludes our proofs for the sum and difference identities. You're also going to be revisiting these on a known identities packet where you'll redo these again because one of these sets of proofs will show up on your future test.